Assalamualaikum and hi everyone. For this presentation, I will begin with the introduction of our selected pump, which is the centrifugal pump. A centrifugal pump is a mechanical device that is used to move liquid by rotational energy from a motor-driven impeller. It converts the mechanical energy from the motor into kinetic energy and pressure energy in the fluid. The basic function of the centrifugal pump is to move fluids continuously from one place to another. When the impeller rotates, it pushes the liquid upward due to centrifugal force, which increases the liquid velocity and pressure. This causes the liquid to flow smoothly from the suction side to the discharge side. Centrifugal pumps are the most widely used type of the pumps in the world. They are commonly used in the food processing, water supply system, chemical industry, and oil refineries because they can handle large amount of liquid efficiently. In general, a centrifugal pump consists of three main parts, which is the impeller, casing, and the motor. The impeller rotates and transfers the energy to the fluids. The casing directs the flow and the motor provides the power to driver in the impeller. As a short background, the centrifugal pump was invented by Dennis Papin in the 17th century. Over time, it has been developed and improved for industrial use, becoming one of the most important machines in engineering today.
Now, I'll be presenting on the components of a centrifugal pump. So, there's a few main components of a centrifugal pump. First, we have impeller. So, this is the rotating part of the pump that transfers energy to the fluid. So, it converts mechanical energy from the motor into kinetic energy, and its shapes and size determine the pump's flow rate and head. Second, we have casing. So, the casing encloses the impeller and guides the fluid smoothly to the discharge, converting the velocity into pressure energy while protecting internal components. Next, we have suction pipe. So, suction pipe carries fluid from the source to the pump. So, it usually airtight, equipped with a foot valve and strainer, preventing debris and air pocket that can cause cavitation. After that, we have delivery pipe. So, delivery pipe transport fluid to the discharge point and designed to handle high pressure and may have valve to control flow. Next, we have shaft. So, shaft connects the impeller to the motor, transmitting mechanical power and torque. It's made of strong, corrosion-resistant material to withstand forces during the operation. After that, we have bearing. So, bearing supports the shaft, reduce friction, and ensure smooth rotation. So, it is important to have proper lubrication and alignment. After that, we have mechanical seal. This prevents leakage where the shaft passes through the casing, maintaining pressure and efficiency. Lastly, we have volute. So, volute guides the fluid efficiently out of the impeller and can be removed for maintenance or inspection. Now, let's move on to the operational principle of centrifugal pump. So, there are 6 points that I'll be explaining to you guys. Let's go. So, for the first operational principle of a centrifugal pump, we have energy conversion principle. The centrifugal pump changes mechanical energy from the motor into kinetic energy that moves the fluid. So, this energy helps the pump to push the liquid efficiently through the system. Second, we have fluid entry at the impeller eye. So, the liquid first enters the pump through the suction pipe into the center part of the impeller, called the impeller eye. So, this area has low pressure, which helps pull the fluid in continuously. Third, we have impeller rotation and kinetic energy transfer. So when the impeller spins, it gives speed to the liquid and throws it outward because of centrifugal force. This makes the fluid move faster. Next, we have centrifugal force and outward flow. So as the fluid moves outward, it gains more energy and speed, flowing toward the edge of the impeller. After that, we have conversion of kinetic energy to pressure energy. So the liquid goes into the bolide casing. There, the flow area becomes wider, so the liquid slows down. And according to Bernoulli's principle, when speed decreases, pressure increases. That will create high pressure fluid ready for discharge. Lastly, we have fluid discharge and continuous flow. So the high pressure liquid flows out through the delivery pipe, and at the same time, the low pressure at the impeller center will keep pulling in more fluid, so the flow continues smoothly.
Next, let's look at the application of centrifugal pumps. First, in water supply and distribution, they are used in municipal systems to deliver clean water to homes and industries. They are also common in irrigation systems that pump water from wells or rivers to agricultural fields. In industrial application, centrifugal pumps are used to transfer liquids such as chemical, oil, and beverages. They play a vital role in food, pharmaceutical, and chemical industry by ensuring smooth and continuous fluid movement throughout the production lines. In agriculture, these pumps are used for irrigation and fertilizer solution, helping to maintain a steady water flow in large-scale farming systems. And for wastewater and sewage treatment, they help transport sewage, sludge, and treated water, keeping the flow steady during the treatment process. And lastly, in power plants, centrifugal pumps are used as boiler feed pumps to supply high-pressure water, and they also circulate cooling water for turbines and condensers. Let's move on to the advantages of centrifugal pumps. One of the main advantages is their simple design and easy operation. This makes them very user-friendly and convenient to maintain. Next, they provide a smooth and continuous flow of liquid, means there is no pulsing or interruption during operation. This is especially important in food processing, where we want a consistent flow for uniform product quality. Centrifugal pumps can also handle large volume of liquid efficiently, which makes them suitable for industrial scale operations such as beverage or dairy production. Another benefit is their low maintenance costs, since they have fewer moving parts compared to other types of pumps. They require less frequent servicing. They are also compact and lightweight, making them easy to install in different setups without taking up too much space. And lastly, these pumps are ideal for liquid with low viscosity, such as water, milk, or juice, which are common in food.
Now, let's talk about the disadvantage of the centrifugal pumps. Even though a pump is a very wide use, it still has some limitations. First, it cannot handle very viscous fluids. That means that if the liquid is too thick, the pump will not work efficient, because it depends on the flow of the fluid to generate pressure. Second, it is not suitable for the high pressure applications. Centrifugal pumps are designed for moderate pressure, so they are not ideal for a system that require very high pressure. Third, it must be primed before starting, unless it is a self-priming type. This means that the pumps need to be filled with the liquid before operations to prevent air from stopping the flow. Next, the efficiency drops when there is flow variation. In other words, if the flow rate changes, the pumps will not perform in the best condition. Lastly, air or the vapor in the pump can cause cavitations, which may damage the impeller and reduce performance. So, even though centrifugal pumps are very common and useful, there are some of the drawbacks that we need to be considered when using them.